It was supposed to become a marvel of American aviation, fast, powerful, invulnerable. Instead, it was called a Frankenstein in the sky, the strangest plane of the war, and even the disgrace of General Motors. Two hearts beat in its engine, assembled into one, but this power led to overheating, accidents, and tragedies. Tests ended in catastrophes, pilots feared sudden spins, and engineers desperately molded new tails and wings, turning the machine into an even more ridiculous monster. And all of this happened at a time when the war wouldn't wait. Other fighters were conquering the skies, while this project remained a symbol of wasted ambitions. Why did the aircraft, once hailed as a legend, end up in history merely as an example of how not to build a weapon? The answer is hidden in the details, and they are much darker and more surprising than one might think. In the very first years of World War II, American pilots found themselves at a disadvantage. Their main fighters, like the sturdy but aging P-39-era Cobra, could only hold their own confidently against mediocre machines. But when the best examples from Japan and Germany appeared on the horizon, the advantage quickly went to the enemy. It became clear to the American command that to change the course of the air war, a new aircraft was needed that would not just equalize forces, but surpass any opponent. The military put forward requirements that seemed almost fantastic for the time. They needed a fighter capable of accelerating to over 440 miles per hour, climbing faster than 5,500 feet per minute, and covering a distance of up to 2,500 miles without refueling. Added to these characteristics was powerful armament capable of destroying both enemy fighters and bombers. The task sounded like a challenge to the aviation industry itself, to create a miracle plane that would become a new symbol of American aerial supremacy. This project promised to revolutionize the perception of aviation capabilities. The military saw in it a guarantee of sky defense and a chance to turn the tide of the war. The engineers, meanwhile, understood that such an order would require not only new solutions, but also the courage to step outside conventional designs. Thus, amidst hopes and ambitions, the idea for an aircraft was born, one that was destined either for glory or to become a symbol of failure. At this moment, an industrial giant, whose name was rarely associated with combat aviation, entered the fray. General Motors, accustomed to mass-producing automobiles, decided its expertise could be applied to the skies. Corporate executives were confident that if cars rolled off assembly lines by the thousands each month, a fighter could also be turned into a mass-produced product. This approach promised the Army rapid replenishment of the fleet with new machines and significant time savings in conditions where every month of the war was costly. The central figure in this plan was the designer Donovan Berlin, who had previously worked on the P-39. His task was to devise a project that combined the power of a next-generation fighter with the simplicity of car assembly. Instead of designing every detail from scratch, he proposed a daring solution. Take ready-made components from existing aircraft and combine them into one machine. Wings, tail assembly, landing gear, everything could be borrowed from models already in service and mass-produced. On paper, it looked like a brilliant combination. On one hand, resource savings and accelerated timelines. On the other, the possibility of assembling an aircraft with characteristics superior to anything the United States had at the time. Berlin and his team assured that the new fighter could be produced in a matter of months, and if necessary, mass production could be established as if they were talking about passenger cars. This idea looked like a breakthrough, promising not just a new aircraft, but a revolution in aviation. When the project began to take shape, Berlin's concept revealed its full peculiarity. The new fighter was not created as a single, harmonious structure. It was literally assembled from parts of already flying machines, like a construction kit. Elements from the Mustang, which had already proven itself as a reliable fighter, were taken for the wings. The tail section was borrowed from the Dauntless dive bomber, and the landing gear struts were chosen from the Corsair. At first glance, everything seemed reasonable. Proven components, adapted to a new fuselage, should have sped up development and simplified production. But when the engineers brought all these elements together, the aircraft turned out to be less elegant and more strange. The Corsair had characteristic gull wings, allowing it to use short landing gear struts, but they were inexplicably placed on the straight Mustang wings, which looked absurd and created a risk of technical problems. The tail from the Dauntless also didn't fit the new design. It was calculated for a different weight and different loads. Thus, the fighter, conceived as the embodiment of practicality, gradually began to resemble an engineering monster. Its appearance raised questions. Organs that were too different had been stitched together. This mix looked as if the plane had been hastily sewn from whatever was at hand. Specialists began to doubt whether such a machine could meet the high demands of the military. A troubling question hung in the air. Would this creation become the Frankenstein of aviation, beautiful only in promises but useless in reality? The true pride of the future fighter was supposed to be its engine. Naturally, such a miracle plane required a motor of special magnitude. The choice fell on the Allison V-3420, a power plant that itself looked like an experiment. It was developed by combining two already proven Allison V-1710s, widely used in Lightning's, Era Cobras, and King Cobras. Two familiar hearts were merged into one giant, resulting in an engine with a power of almost 3,000 horsepower. To tame this monster, engineers devised an unusual scheme. The engine was placed not in the nose but behind the pilot's cockpit, closer to the center of the fuselage. Two long shafts extended from it, converging into a single gearbox and driving counter-rotating propellers with 6 blades each. On paper, everything looked astonishing. Incredible power, reduced torque effect, and space saving in the nose for armament. But the brilliant idea resulted in a multitude of difficulties. This arrangement made the cooling system extremely awkward. Air intakes affixed under the fuselage looked like alien growths and were poorly effective at their job. The complex double-drive gearbox required jeweler-like precision and became a source of constant failures. Every extra mechanism added weight and reduced reliability. On the outside, the new fighter promised to be the terror of the skies, but inside, the structure looked more like a technical experiment than a finished machine. And although the power figures were impressive, reality quickly showed that the monstrous, double-hearted engine was bringing more problems than solutions. When the time for testing arrived, expectations collided with harsh reality. The first prototypes were delayed by many months. Instead of the promised 6 months, the machine appeared closer to the end of 1943. Delays in military aviation were commonplace, perhaps, but here, every week was costly, as the front needed new fighters immediately. When the aircraft finally took to the air, joy quickly turned to disappointment. The engine, which promised almost 3,000 horsepower, barely delivered the required performance and overheated after a few minutes of flight. The air intakes couldn't cope, and the complex transmission became a source of perpetual issues. But the most dangerous thing was that the machine itself behaved unpredictably. During certain maneuvers, it would suddenly enter a spin, and escaping this uncontrolled spiral was not always successful. The situation became even darker after one of the prototypes crashed during a test flight. The pilot was unable to cope with the sudden loss of stability. This was an alarming signal for the project. The designers understood that they were dealing not with a minor malfunction, but with fundamental flaws in the design. To save the concept, engineers began to rework almost everything they could. The tail assembly was enlarged, hoping to provide stability. New ailerons were fitted to the wings, but hydraulic boosters had to be installed to control them. The pilot couldn't manage the load manually. The center of gravity shifted backward, so the nose section was lengthened, adding extra weight. Every step taken for correction turned the aircraft into an even more complex and heavy creation. What was conceived as a simple kit of ready-made parts became a unique but overloaded machine that was increasingly difficult to perfect. Testing resembled a struggle against the project itself, rather than a search for solutions. And the further the engineers went, the more obvious it became. The more they fixed, the more the entire concept crumbled. By the time the redesigned XP-75 finally began to show somewhat acceptable results, the war had already moved on. In 1942, the American military genuinely needed a swift interceptor, capable of catching the fastest enemy machines. But by mid-1944, the situation had changed drastically. Germany was retreating westward, losing factories and experienced pilots, and its air force was no longer the same threat. The Japanese in the Pacific also switched to the defensive, and with each passing month, it became increasingly clear that the future of air combat lay not in short intercepts, but in escorting heavy bombers. Long-range escort fighters were needed. capable of leading entire groups of bombers over enemy territory and protecting them from attacks. And here, other machines were already shining. The P-51 Mustang, fitted with the new Merlin engine, proved superb. It flew fast, high, and could escort bombers for 1,000 kilometers. The P-38 Lightning, though heavier, also confidently served as a guardian on long routes. Against this backdrop, the XP-75 looked like a latecomer, trying to fill a niche that was already firmly covered. Its speed of over 400 miles per hour might have impressed 2 years earlier, but now its competitors flew faster. Its complex engine and unstable behavior made it an unreliable partner in formation. Even if it were perfected, there was no longer any need for it. The Army didn't require a new experimental interceptor when proven machines were perfectly handling the task. Thus, the main enemy of the XP-75 was not so much its technical flaws as time. It appeared at the wrong moment. The war had changed the rules, and the role for which it was created was already taken. When it became clear that the project would not meet expectations, the Army quickly cooled to the loud promises of General Motors. Contracts, which had recently sounded like a decree for non-stop factory work, began to be reconsidered one after another. Out of the thousands of planned machines, only 14 specimens were ultimately built, and not one of them ever received full armament. Essentially, the XP-75 remained a set of brilliant prototypes that resembled laboratory experiments more than a finished weapon of war. For the corporation, this was a painful blow. The ambitious plan to go down in history as the company that successfully applied the assembly line approach to aviation ended in failure. Instead of glory and an aura of revolution, Fisher and General Motors gained a reputation as risky experimenters whose machine proved too complex and unreliable for mass production. Today, only one aircraft, miraculously preserved and restored, serves as a reminder of that project. It stands in the National Museum of the United States Air Force in Dayton, gleaming with polished aluminum. Its appearance is striking. There is something subtly strange about it, as if this plane exists on the border between the possible and the impossible. But for those who remember its history, the shine of the plating only emphasizes the bitterness of unfulfilled hopes. A triumph could have been here, but only a display case remains, a reminder of how high ambitions can turn into disappointment. The story of the XP-75 often raises the same question. Can it be called the worst plane of the war? Formally, it looked like a failure. Loud promises were not kept, and the real benefit to the front was zero. But if one considers it, the title of the worst in World War II aviation is too debatable and layered. After all, compared to the XP-75, there were much stranger projects. The German Me-163 Comet actually went into production and was even used in combat, but it often brought disaster to its own pilots rather than the enemy. Its unstable fuel turned every flight into a game with fire. The Japanese Yokosuka MXY-7 Oka, designed as a piloted rocket, looked like a desperate attempt to compensate for the lack of resources at the cost of human lives. Such machines, even when produced in the hundreds, barely changed the course of the war, but claimed countless lives of their crews. Against this backdrop, the American XP-75 seems more like a technical experiment than a catastrophe. It never reached combat, did not cause mass losses, and did not destroy the reputation of the country's entire air force. Its problem lay elsewhere, in project management. Once the idea of interchangeable parts, the very reason the project began, was abandoned, the mistake should have been admitted and the program closed. Instead, it was dragged out, pouring effort and resources into an aircraft that was moving further away from its original concept and becoming unnecessary. The XP-75 was not the worst plane of World War II. It became a symbol of how a good idea can get bogged down in endless reworks and incorrect decisions. This is not a story about an absolute technical failure, but rather one of the most striking examples of how mismanagement can doom even the most ambitious plans.